All right, so we're going to go ahead and get started today. We're going to start by working on one problem that basically you'll upload as today's quiz grade. And first, I'm going to introduce you to some websites because right now you're probably at the time where you're feeling like, hey, maybe I could use some extra practice or something like that. So this is the first website we'll look at where we'll get our first problem from, which is Project Euler. What these are, they're all mathematical problems that now technically they could be solved by hand if you had enough time and patience and reams of paper. A couple, years on your side for some of them. But thanks to the power of a computer, we can actually solve a lot of these problems pretty quickly. So we'll go back to here. Another good website for practicing your programming is CodingBat, which has a lot of exercises in Java that you can practice. So if you need to practice if you feel like you need additional practice to go off the things that you need, you're going to go to this website. Now, let's go ahead and, so I posted 5 videos last night for this lecture. Not last night, but that would have been a bit tough. But like on Friday evening, I posted about 5 videos for you to watch over the weekend. Hopefully you were able to watch all, if not, some, if not all of them. Yes? One of them is not working?
Second to last. YouTube playlist, but from American has an on-campus video model. When you look for YouTube playlist.
So let me go ahead. I checked it on I checked it on my end. This for the fourth one. Error does this. Interesting. I think it's missing a digit or something. The URL does look a bit shorter. So okay, I'll fix that. That one was more on if else's. Okay. So sorry about that. All right. So, but hopefully they were pretty short and easy to digest pieces. Okay. So today we're going to put together a lot of what we learned, and we're going to look at the first problem of Project Euler. Now this problem, so Project Euler, they keep track of how many people have solved this problem. And to solve a problem, you make an account and, and verify you got the answer that you got. Problem 1 has been solved by a lot of people, and as you can see there, once you start getting to page 5 or so, there's a lot of, just less and less people solve these problems. They're in the thousands for most of them, rather than, say, hundreds of thousands. So they get pretty tough, and also people get bored. So, but we're going to look at this one, and I like this one because if I'm learning a new programming language, so if I start with if I'm starting in Java and I want to learn new programming language, I feel like I've got a good grasp of the basics if I can solve this problem in the language I'm learning. Like Python, once I could do this in Python, I'm like, okay, I understand the basic Python syntax, even if I don't completely understand the language. Same with Ruby or Go or C. Once I can do this problem, I feel like I've got a nice grasp of the syntax of the language, because this problem brings together basically everything that you've learned. Multiples of 3 and 5. So the problem is, if we list all the natural numbers, so those are basically your positive numbers, your positive counting numbers, positive counting integers, all the natural numbers below 10 that are multiples of 3 or 5, you have 3, 5, 6, and 9. Okay? That makes sense to everybody so far? Okay? Add those together, you get 23. Okay? So the sum of all these is 23. Now we want the sum of all the multiples of 3 or 5 below 1,000. Okay? So we're asking what is the sum of 3, 5, 6, 9, 12, 15, right? So and 10. Can't forget 10 as well, because that's a multiple of 5. So 3, 5, 6, 9, 10, 12, 15. And so basically, if it's a multiple of 3 or 5, then we need then we want to add it together. So this brings together a whole lot of things. So let me go ahead and give you like what it's bringing together. So hopefully you know where to start on this one. Okay, and you can do this in a method, or you don't, or you can do it as part of a main. But you will be doing it in pairs. Okay, so no need to rush and get a head start. Okay, so it's going to bring together if statements, right? Because you need to be able to check if a number is a multiple of 3, or if it's a multiple of 5. You got to do modular division to check if it's a multiple of 3 or 5. You need to check for every number that's below 1,000. Well, every positive number below 1,000. They're infinite, and there's an infinite number of numbers less than 1,000 if we include the negatives. So for all the numbers from 1 to 1,000, you got to check if all of them are multiples of 3 or 5. And then finally, we need to do what's called a running sum, right? Then that's the idea that basically that we keep a sum to tabulate the total of this, which is something that you should have done which is something that you probably learned to do when you were doing this sum of squares problem back in the last assignment. So we'll do this problem, and then we'll go on to maybe we'll leave it up to you after that whether we want to work on some of the loop problems or the pizza problem. Okay, so for right now, let's go ahead and give you guys some time to work on this problem. Go ahead and get it into pairs. I've opened up a space on Canvas for you to submit this on Canvas when you're done with it. So once you submit this, you've got credit for today. Okay. So okay.